Okay, so the second page of this lesson is really good practice. We just want to remind you that the distributive property also is applied to square roots. If you have a square root outside of a group like this, you literally just distribute the square root to each term and then simplify whenever possible. So the square root of 2 times 5 is going to be 5 root 2, and the square root of 2 times the square root of 8, we know that we can multiply the square roots and we end up getting the square root of 16, which actually gives us a perfect square, right? So we know that this ends up being 4. So this is 5 root 2 plus 4. And I believe it is common practice to always put rational numbers before irrational numbers. If someone can Google that and lay it down in the comments, that'd be awesome. But I believe you always put rational numbers before irrational numbers. We kind of give a priority to rational numbers. Uh, I'm going to go ahead and check that after this. Okay, so number 10 says, does the expression the square root of x plus the square root of 2 squared equal x plus 2? Wow, this is a huge question. It's probably one of the most I guess, misunderstood concepts. People always make a mistake on this. So I'm just going to give you another example. Okay. So, for example, if I gave you 1 plus 5 squared, what do we think that is? Okay. Some students might accidentally think, oh, does that mean I distribute the 2 to each term, or the square, I should say, to each term, and I make that 1 squared plus 5 squared? That seems like it's reasonable, right? You distribute the square to each term. But even though that seems like it's reasonable, this is totally false, right? Think about it. What is 1 plus 5? What is the sum of that? That's 6. And 6 squared is totally different than 1 squared plus 5 squared. Okay. So this is where you have to be very careful. I know it seems very reasonable to just square both terms, but you can't. You actually have to do the square root of x plus the square root of 2. So it's times the square root of x plus the square root of 2. So square root of x plus the square root of 2 times the square root of x plus the square root of 2 is exactly what this is. Okay. Later on, we'll learn about this. This is actually what we call foiling. If you've ever heard of this 4-letter acronym, it's called foiling, where you do the first term minus the first term, the outside terms, the inside terms, and then the last terms. Okay. But the one thing you have to realize is you must not square both of these. And the main reason is because it's an expression. So if a power is outside of an expression, you cannot simply just square each term. Okay. This is definitely something that I would love to explain in further detail when I have more time. But just realize that you cannot square each term because it's kind of like an expression. You cannot just distribute a square to each term like that. If it was multiply, or if this was a product, and this was just one term, of course you could. Okay. All right. So let's go to 11. We have 6 problems to do for this page, and let's get right to it. So I'm going to move a little bit at a fast pace. And if you feel like you want to just pause the video, feel free to do that. Okay. Square root of 3 times the square root of 6 is the square root of 18, minus the square root of 3 times the square root of 12 is the square root of 36. Okay. Both of these are pretty good numbers, easily simplified. This is the easiest because this is a perfect square. So we know that this is the square root of 3 times the square root of 2, and this is simply just 6. Oh, I'm sorry. This is the square root of 9 times the square root of 2. So that becomes 3 root 2 minus 6. You could leave it like that. I'm going to go ahead and quickly Google something right now and see. Do rational numbers have to be placed before irrational numbers? In standard form. You know what? I can't really find the answer that quickly right now, but let's just go ahead and follow what I did earlier. And let's always put the rational number before the irrational number. Okay. Remember that the negative is always attached. So you can't just say 6. It's negative 6 plus 3 root 2. That's the same thing as 3 root 2 minus 6. Okay. All right. So let's go ahead and try number 12. We have 3 plus 2 root 20. Root 20 is going to be root 4 times root 5, which gives me 2 root 5. And then you combine with this 2, and it gives you 4 root 5. So you really just have 3 plus 4 root 5. That's the left side. And then on the right side, I'm going to go ahead and do 4 plus the square root of 45. And I end up with the square root of 9 times the square root of 5, which is 3 root 5. Okay, so now we just have to combine all of this. And actually, that's not a bad, pair of things to combine. We know that 3 plus 4 gives us a grand total of 7. And then 4 root 5 plus 3 root 5 is going to give us 7 root 5. Okay. Number 13 deals with the concept that we kind of talked about on the previous lesson, and it is called rationalizing the denominator. You must not have a denominator that has a radical. This is a very, very important concept, class, especially when you go to high school. You'll be seeing questions like this all the time, and you have to realize you must not ever leave the denominator with a square root or a cube root, for that matter, any kind of root. You have to always rationalize it. So let's go ahead and do that right now. We realize all we have to do to rationalize this square root of 3 is to multiply the top and the bottom by the square root of 3. This is a group, so it has to be protected by parentheses. And again, the value of square root of 3 and over square root of 3 is just a value of 1. So we're not really changing the value. We are just showing it and representing it in a different way. Okay, let's start with the numerator. The top becomes 2 root 3 plus radical 3 times radical 3. It's simply just 3. And that's the same thing for the bottom. This is the final answer. Okay, can you switch the 3 in the front? Yeah, you know what, I'm starting to realize I'm not sure if that's a concrete rule. Maybe it's just out of standard form, or it's just something that people usually tend to do. But I've also seen this. Okay, now I'm just immediately when I look at this answer, I realize that some people might say, well, Mr. Kuo, can I simplify these two? Yeah, you can. An alternate answer, I'll just write it right now, is going to be if you just divided both of these terms on the top by 3. So an alternate answer is 2 radical 3 divided by 3 plus 1. Okay? But I feel like if you were looking at an answer key, this is exactly how the answer would be left. You could keep going and kind of do it this way, but this is just, once you arrive to this and it's already simplified, you should just leave it. Okay. All right. So we have 3 more problems to go, and let's go ahead and do this. Okay. So this is 2 root 7 minus, wow. So this is a radical 7, and you can actually just do radical 7 times the entire radical 112. Okay, so right away I realize I probably should simplify 3 radical 112 first before I actually multiply the radical 7 with it. Because I don't want to deal with something that's a 3-digit number. That's like 784 or whatever it is. So that's just seems very, very challenging. Okay, so 112, what is a perfect square that's a factor of 112? I immediately think of 4, potentially 6, but I'm just going to use 4. And I think 4 gives me, what is that? 4 goes in 11 twice, and I get 32. And then I get, that's 8. Okay, so again, maybe it's good that I'm showing you this, but this tells me that this is not the most optimal choice because square root of 8 actually can still be simplified. Okay, so but let's go ahead and do this. This becomes 2, and this becomes 2 root 2. So it finally becomes 4 root 2, and then I don't forget about that 3, and ends up being 12 root 2. The fact that this was 4 root 2 tells me that 16 was a factor of 112. And that probably would have been 7. 16 times 7. Yeah, that would have worked. Okay, that's okay though. And then you get, so 3 radical 112 is actually 12 root 2. Okay. But I realized that I already distributed the radical 7 here. So then now I have to distribute the radical 7 here. So basically, I have to multiply that number by a radical 7. Okay. This is decently tricky. There's so many steps. And if you don't know what you're doing, you might want to take a pause and just see exactly why everything is what it is. But this ends up being 2 radical 7 minus 12 radical 14. And I believe that's the final answer. So let me just double check my work right now. Okay. 3 square root of 112. 112 was 4. Wait, what? 4 and. Ooh. This should have been. Wow. Okay. So I totally messed up here. I don't know why I said 4 and 8. 4 goes into 112 28 times. 28 times. So this becomes 2 root 7. I totally messed this one up. And I apologize. It's supposed to be 4 root 7. And that gives me 12 root 7. So I kind of messed up on this root. And that actually should give me 4 root 7. Then when I multiply the root 7 with another root 7, this gives me 49. I apologize, class. So this is 12 square root of 49. So this is really 2 root 7 minus 12 times 7. Wow. Okay. And 12 times 7 is 84. So the final answer would have been negative 84 plus 2 root 7. Give me 1 second, and I want to double check that answer. Yes. So yeah, that was a terrible mistake by me. 4 times 8 does not equal 112. 4 times 8 is 32. 4 times 28 is the 112. So this should have been a square root of 7, square root of 7 the entire time. And then square root of 7 times square root of 7 gives me actually a perfect square. Okay, so I believe this is right, but give me a second to double check.